Hello, everyone. Welcome to this group discussion on digitalization with focus on ITTC aspects. I am Pierre Ferrand from Central Nantes. I will be moderator of this session, and we have two colleagues who will give their view on this topic. Dr. Bas Buchner from Marine, Netherlands, and Dr. Buki Kim from CRISO, Korea. And they decided that Dr. Kim would begin.
Okay.
Okay, the floor is yours, and you can share your screen and give your presentation. Thank you.
Okay.
So I remind everyone that you can still post questions using the web tool during the presentation.
Yes. Can you see my presentation slide?
Yes, it's okay. You can start.
Yes. So, okay. Hi. My name is Buki Kim, representing CRISO in Korea. In the beginning, I was asked to talk about the digitalization in marine hydrodynamics. I was a little bit puzzled on what to say about this topic. But soon I decided to introduce the related research activities of CRISO in recent years. Nowadays, in Korean shipbuilding and ocean engineering society, many interest of using digital technology has been increased along with the digital New Deal policy that is promoted by Korean government. Actually, I have already provided the pre-recorded presentation about this topic in a full version. It is about 15 minutes presentation and currently available for download from ITTC website. For this session, in the following slide, I will present them again in a short version for 5 minutes. Over the years, CRISO has been making efforts to establish virtual twin and wave tank by applying the state-of-art CFD techniques. As you are well aware, CFD in marine hydrodynamics is now commonly used everywhere and becomes bread and butter for the ship and offshore engineer. In many Korean shipbuilding companies, CRISO in-house CFD code, WEBIS, is popularly used for evaluating the resistance and propulsion performance of a ship. WEBIS code has been validated with extensive model tests obtained from CRISO and other model basins. For our own judgment about WEBIS, we find we can achieve good accuracy enough, especially in model scale calculations. The full scale performance of ships may be predicted. However, how to validate the full scale result based on the CFD simulation remains still an issue for us, and it is ongoing research project. CRISO has also been putting a lot of efforts on developing a numerical wave tank for offshore applications. Our goal is more thoroughly to reproduce and predict hydrodynamic characteristics of offshore structures in virtual space, eventually help to design an offshore structure with a better global performance and the structural performance. Our numerical wave tank is being developed based on open source, such as OpenFOAM. Our philosophy to implement the important function in there are sustainable development, high fidelity and efficient simulation, and customization of the state-of-the-art CFD techniques. Over the years, we have established the database system of ship hull form and propeller data with its model test and CFD results. From our database, the speed, power, and propeller RPM can be predicted based on machine learning regression model. And in some situations, the hull form can be optimized and further improved based on the established database. For propeller design, When the hull offset is given, the local flow in propeller plane can be predicted by the offset-based machine learning. We are trying to update this database system with the newly acquired data from our model test and CFD simulations. We believe this kind of database system is very useful, especially when the quick and dirty calculations are needed at early design stage of a ship. For the purpose of making an optimum design of a ship hull, propeller, and energy-saving device in a simultaneous manner, we are developing a web-based design platform, and it has already been applied to several projects. The user interface in this web-based design tool has the advantage of the easy access to previous designs, and this can give the ship design competitiveness, especially for small and mid-sized shipyards. For the information available in the database, in addition to main particulars and design geometry, CFD and experiment results are also established in the private cloud. And then standardization for design procedures and CFD simulation cases is established for applying the consistent design procedure. We believe this streamlined and standardized approach would guarantee the same level of design quality, regardless of entry level or well-experienced ship designer. The several design candidates can be obtained through our design platform. Later on, the final design can be determined based on the resistance and propulsion model test in a towing tank. In CRISO, digital twin has not yet reached the level of evaluating the performance of offshore platforms. However, we plan the digital twin to be applied to the asset performance management of marine renewable energy system in the very near future. The digital twin technology can be utilized for the performance monitoring and evaluation of offshore renewable energy systems to failure prediction, optimal control, and asset performance management for owners. The marine renewable energy system has various mechanisms, such as the conversion of the renewable energy to mechanical energy and mechanical energy to electrical energy. And the application of the digital twin is expected to bring the technical transparency and economy during the conversion process. CRISO has a pilot OWC wave power plant in the west of Jeju Island, Korea. Currently, it is producing electricity based on the ocean waves, and we are making efforts to increase the capacity factor. The wave power plant is being monitored in the form of digital twin, as you see in the right-hand side figure. And our efforts are being made to innovatively improve the control and monitoring the system in the near future. For global motions of ships and offshore structures in moderate sea conditions, CFD can provide a highly accurate solution, and some of our analysis results have been already applied in the design process. The video clip in the left-hand side shows the CFD example result of analyzing the behavior of FPSO structure, coupled with the mooring system and riser. We believe CFD will be applied more and more in the design phase in a routine manner compared to the other current methods, such as potential flow method. The right-hand side figure is example of a structural digital twin from Exelos company. Exelos patent finite element analysis technology was applied to perform the real-time finite element analysis, even with the very huge number of finite element meshes. The structural Structural digital twin is a physics-based model of the asset that can represent its entire physical counterpart in absolute details and accuracy. The structural status of the model can be updated with the measured loadings and inspection data on a regular basis, providing the ability to carry out the structural assessment based on the as-it-is condition from anywhere and at any time. In our opinion, CFD and finite analysis method will be an alternative approach for design validation and asset performance management for the owners. I want to bring up several remarks to summarize my talk today. Digitalization is very essential and inevitable technical area for competitive ship and offshore design. I think digitalization can provide the maritime industry with a better design and better performance and efficient solution. Digitalization will contribute to the recent driving force of the ship and offshore design for safe, autonomous, and zero-emission technology. In my opinion, in upcoming years, standardization, reliability, accessibility, security of marine digitalization for marine hydrodynamics should be addressed and discussed what to do in terms of ITTC aspects. Thank you for listening.
Thank you, Dr. Kim, for your presentation. So I propose that it is complemented by Bas Buchner's presentation, and then we will move to questions and comments.
Thank you very much. I hope this is, you can see this properly. Yes. Thank you also, Buki Kim, and I can recommend everybody to have a look at the video, because it's a very complete, good overview of what is happening in the field of digitalization. I'm complementing the presentation by Buki Kim with my presentation, where I start with the actual objective of our field in hydrodynamics, and that is, if I summarize it, making shipping more clean, safe, and smart. And we can be sure that digitalization will be a very important part of our field. And if you look to the trends around us, simulation-based design, digital twins, as Buki Kim already referred to, but also virtual reality, augmented reality, and related to that, serious gaming will be important. And of course, handling big amounts of data, artificial intelligence, and machine learning are very important in the trends around us. And if I then look to the situation of a typical operational problem, in this case, on the view, I have a bit of a problem that I see something else on the screen. Then the sheets on the presentation are different from what I'm presenting. What do you see, just for checking, Pierre?
Model testing, safety, and then.
Yeah, and okay, that's good. Then my screen is stopped. Okay, then that's fine. Okay, then I just proceed. But if you look to this problem, a complex frigate in a maneuvering sequence, then we used to analyze that by model testing. There's something wrong with the system, I'm afraid, but because this is not a moving video. And after the model testing, we are focusing on the application of CFD, but after that, we will see the application of data. And if I then focus on the challenges that are ahead of us, then you see, and you look to the challenges for ITTC, we can state that ITTC is a quality assurance organization for hydrodynamic research to give accurate answers to our clients. So clean, safe, and smart operations in operational conditions. And we all know already that hydrodynamic research is broader than model testing. And that I believe that digitalization and the use of data puts the focus on the right topic. And that is performance in operational conditions. So not just the design conditions, but also the performance, more importantly, in operational conditions. And one of the other things is, of course, that digitalization is not new to us. We are looking to data analysis, advanced data analysis for a long time, CFD, time domain simulations, both in our simulations, both in frequency and time domain. And but the question is, what will be our future role? And I think that the ITTC should remain the quality assurance organization for hydrodynamic research, because in the end, the goal is to have accurate answers for our clients. And digitalization requires other types of expertise, CFD, simulations, data science. And we also have to admit that we do not have all that expertise ourselves now. And the question is, how do we develop that expertise? And importantly for ITTC, should we extend the membership to other parties that perform hydrodynamic research, not with model basins, but maybe based on data? And then the question is, who will be that future partner? So there is a big challenge in quality assurance for CFD and data science compared to model testing, because water molecules are the same everywhere, all around the world, but numerical models and data analysis algorithms are not. So how do we deal with it? The challenge probably for quality assurance is even bigger than what we have with model basins. And there's of course also the question of the quality of the data, and how do you define the quality of data? And one of the big challenges for me is, if you look to data-driven solutions compared to model-driven solutions, that the algorithms comes with a relation between the data and the things you want to understand, but the explainability of what is happening in the methodology is actually pretty limited. And the question is, do data-driven solutions actually provide predictions? And finally, I think an important question to be discussed is, how do we get safe access to the data? So I hope these questions stir up some discussions between ourselves and between the audience.
Thank you. So yes, we have at least two written questions. So my duty is to read these questions, and yours would be to answer those questions. First, there is a question by Young-Won Kim, which is the following. ITTC has been an organization which has made the procedures for experiment in past, and currently we are doing many activities for numerical computation. Do you think that we can extend such activities to make procedures related to digital-based analysis? That is, does ITTC should create some standards such as guidelines and procedures for digital techniques and analysis? So this is in mirror with some of your words, Bas, I guess, at least, and maybe Buki. So I don't know how you want to react to this.
Bas, can you go first for the answer?
Okay, good point there, Buki. No, I think, as I mentioned in one of my first responses, I think we have a responsibility, because if you want to give reliable answers to your clients, and we have to use the latest tools from CFD, time domain simulations towards data science, we have to work together to come with a good framework for quality assurance. So it is our responsibility. But our challenge, I think, is that we are a community of model basins that extended their activities towards CFD, to other simulation types. But now this is all model-driven, understanding based on the understanding of physics. And now we have to bring in the data-driven technology. And that also means, in my view, and I think it's also complex, to bring in other parties as part of our ITTC community.
Yes.
But I'm interested in how other members think about it. So maybe Buki, you can respond to that.
I think with the CFD computations, basically you can generate any numbers, but sometimes we can rely on those numbers. Then how we can assure the accuracy and how we can assure it is a reliable solutions. So, but even if with the same theory, depending on the who who make a program, and then who can generate the programs, the results can be different. So we need some example cases and experimental cases that can assure the reliability of the code. So that kind of the actions should be discussed within the ITTC, I think. So I don't know.
But do you believe that we need also other members as part of the ITTC that have, for instance, not access to model basins, but they have expertise in the field of CFD or data science? Because if I look around, hydrodynamic research is broader than model basins. And I think we should acknowledge that, and we have to take into account, we have to invite these people to become full members with full responsibility within ITTC to make sure together that also people with a more numerical or digital field can contribute to our community that is focused on the quality of our results. But I fully agree that we still need model tests for validation, but I think we have to have other people on board as, let's say, full participants.
Yeah. I don't think a CFD people's goal is to get rid of a model test.
No.
So you have to live.
Maybe I can
live together.
comment that.
Yeah.
I have a view on this, is that regarding CFD, I think we are mixing advanced and validated solutions with the frontier developments all in the same block. When you do experiments within ITTC, usually you talk mainly about what can you do with existing sensors which are validated, qualified, etc., and you focus on procedures, how to best use those tools. Maybe a first step is to have the same type of approach with simulation tools. And I think it's not done in that way already. That is, for me, there is a separation with development of new numerical methods and how to best use existing tools. Finite volume methods with a rounds approach is almost the same everywhere, more or less. And there are rules for converged solutions. Then one question is how to best use this just as a tool, just like basing or whatever. And next, what will be the future developments of CFD tools? That's my point. I don't know if it clarifies, but okay. It was the first question by Yamun Kim. First, there is a comment by Gerhard Trasser who says that for the future of ITTC, it's already been decided to also accept members with CFD capability for commercial work. Okay, so that complements your comments. And then there is a question by Didier Fréchou, and Didier, if you're there, maybe you can ask the question yourself, or I can read it. But are you there? Okay, no. So I will read the question by Didier. Thank you very much for these two very interesting presentations on the future of hydrodynamics. My question is regarding the level of computer power and time that is required for the different digital-based analysis we presented. I'm thinking of three examples you mentioned in your presentations. First, CFD simulations of ship maneuvering in waves with rotating propellers. Second, big data analysis for underwater radiated noise using machine learning techniques. And three, structural digital twin for offshore engineering. Looking forward to your answers. So three different topics.
Yes. So about the maneuvering simulations in the waves that I showed in the presentation, for turning circle simulations, it takes about a week with the PC cluster with the 60 cores.
Okay.
And the big data analysis on underwater radiated noise, actually, at this stage, we are trying to build up the database for future big data analysis. Actually, we are collecting the vibration levels and fluctuating pressures and noise and some propeller erosion related data. So we are at this stage trying to build up the database system for big data analysis for the future. So I don't know how long it will take for the big data analysis for underwater radiated noise. So I cannot answer right now, unfortunately. The third question is about the structural digital twin. That is the Excelos company's patented technology. Actually, they measure the loading with the sensor from the sensor on board, and then take it as a loading input for the finite element analysis. Even they have a very big number of finite element meshes. The finite element analysis is real time. That is what they claim. Actually, that's not the Chris's work. I just borrowed from the web. The company name is Excelos. So they claim that the simulation is real time with a very huge number of finite element meshes.
Okay, thank you, Buki. Bas, would you like to complement the answer?
I understand the question from DJ, but I'm not a specialist in the computational power we need. I can just mention, which is in my presentation, that let's say in 10 years from now, 10 years, we went from 10 to 15 cores computational powers to 10,000. And that is basically focused on CFD capability. Of course, if you look to time domain simulations, graphical, so like virtual reality simulations, but also then maybe it's not just a question of CPU, but also of graphic processor units which you can apply. And if you go to the data science part, of course, also the data storage capabilities are very important. So the honest answer is that it is a big puzzle for us at the moment where our investments would be, because there's not a straight line or an exponential line, because it's not that we are making steps from physical research to CFD, but the data science part has a completely different requirement. So it is a very relevant question, but I don't have the answer yet, honestly.
Yeah. There was such a question from one of my colleagues regarding the data storage requirements, which might become a problem.
Oh, but honestly,
we already have a problem. We already have this problem even with video reports that we have to keep. It's terabytes of reports.
One of the things I'm saying, and I can share, is that within Marin, I say to my people, be careful that we are not the place where people start to store their data. It is, you have to, as a research institute, you have to add added value. So clients can store their own data. We have to have access to the data, but you have, with the expertise we have, as hydrodynamicists, and that applies, I think, for all the ITTC members, you should add added value and not become the place where people store the data forever, because it's very expensive and it does not add to the value we can deliver as hydrodynamic research facilities.
Okay, I see that there is another question by Jinbao Wang, which is the following: for ITTC, correlation from model scale to full scale is very important. How do you evaluate if new digital products such as thrust sensor was introduced, the correlation will be improved?
What was the question again?
How do you evaluate if new digital product such as thrust sensor was introduced, the correlation will be improved? So what is the added value of a thrust sensor, if I correctly understand the question? With regards to the correlation.
I don't know exactly what Jingbao means with the thrust sensor, but I fully agree that a validation based on full-scale data should be our objective, and that let's say having access to operational ship data in the end is our final objective, because of course we have all our strong focus on the design condition, but in the end our tools should be able to predict the operational situation, including sailing in a current, sailing in wind, and sailing in a seaway. And then operational data can really help us to validate not just for the design condition, but validating for a fully operational profile. And that is the real challenge, of course, because that is where ships are sailing in.
And we have the same demand, for example, regarding floating offshore wind turbines, for which we have now full-scale models, and we know the value of on-site data, but they are difficult to obtain.
Yeah.
Okay, I think time is over, so maybe we can close this group discussion. But I think Didier has some announcement to do.
Yes, please. So I will take we'll share the screen with you.
So I take this time to thank you, Bas and Buki, for your contribution. This is very much appreciated. Thank you.
Thank you, Pierre. Thank you. You're welcome.
Okay, Pierre, do you see the screen?
Yeah.
Yes.
Okay. Dear all, please, I want to just make a small announcement. It's regarding the EC report. If you have any question on the last presentation of Fabio on Tuesday, we just open to access the Friday plenary session. So participants can go to the start session to submit their question using the QA feature. That way, any question will be collected in the live session. Question cannot be collected in the past session, only on live and future sessions. So you have to go on the Friday tab and post your question on the QA feature as for a standard live session. So it will look something like that. You have to click on preview and then post your question so that there could be a discussion during the plenary session on Friday. Well, thank you. That'll be all for today. Just to remind you that just after this live session of the ITTC, there's one sponsor from Qualisys that will make a show of its technology. So those are interested in can stay for this session. Thank you very much and see you tomorrow.
See you tomorrow. Thank you so much.
Bye.
Thank you all.
Bye.